question, I am given the decomposition of H2O2. So H2O2 decomposes to give H2O plus half O2. And I need to calculate the rate of formation of O2 when the concentration of H2O2 is 0.05. Okay. For that, I need to first write the formula for the rate of formation of O2. As you know that the rate of reaction is equal to change in concentration of H2O2 upon time and twice of change in concentration of O2 upon time. So you can see that the rate of formation of O2, that is half of the rate of decomposition of H2O2. So if I want to calculate the rate of formation of O2, I need to first calculate the decomposition of H2O2. Okay, so rate of formation of O2 is half of the rate of decomposition of H2O2. Okay, and the rate of decomposition of H2O2, that is equal to K concentration of H2O2. Fine. So this I have written from the rate law. So I need the value of H2O2 and I need the value of rate constant. Once I have these two values, I can get the rate of decomposition of H2O2. And after the rate of decomposition of H2O2, I will calculate the rate of formation of O2. So my first aim here is to calculate the value of K. So here we are given this information that the concentration of H2O2 is changing from 0.5 to 0.125. That means it is first changing to 0.25 and then changing to 0.125. So two half-lives are involved in this change. So I can see that two half-lives of this change is equal to what total time is given to me. In this question, I am given that this change from 0.5 to 0.125 is happening in 50 minutes. Okay, so these are two half-lives which is equal to 50 minutes. So the first half-life, the one half-life is equal to 25 minutes. I know the value of the half-life here. From the half-life, I will use the formula K is equal to 0.693 upon T half. Okay, that means 0.693 upon 25. So here I have got the value of K. So I have the value of K. I will write the rate of decomposition of H2O2, which is K into H2O2 concentration. So K is 0.693 upon 25 into concentration of H2O2, which is 0.05. When I will solve, I will get 138.6 into 10 raised to the power minus 5. Okay, now this is the rate of decomposition of H2O2. The rate of formation of O2 will be equal to half of the rate of decomposition of H2O. Okay, and this is equal to, I will do the half of this value. So after doing the half of this value, I will be getting 6.93 into 10 raised to the power minus 4. That means the final answer of this question is 6.93 into 10 raised to the power minus 4. So this is again an important question which has come in JEE Main 2016.